Well, it's a great pleasure to welcome you to our Tuesday discussion today with Lisa Geres of National Park in Berchtesgaden. My name is Christoph Hoffmann, I'm the director of the Rachel Carson Center, and together with Dr. Gesa Lüdecke, the director of graduate programs, we are doing this Tuesday discussion. We're rotating, and it's my pleasure to have Lisa Geres here, who recently, not so long ago, walked us and guided us through the National Park in Berchtesgaden, which was unforgettable. She showed us all sorts of contraptions, traps for insects, day and night, and she will tell you all about that and much more. Lisa actually comes from Munich. She reminded me just now, she says she knows how to get to the metro. She has to get back tonight and be up early in the park tomorrow morning in the Alps, which is a long trip. Lisa all the time wanted to be in the mountains. So sometimes you see postcards of Munich with mountains in the back, but they're not as close as they appear on the postcards. There's a little bit of a seed there. But from the beginning she wanted to be in the mountains, and she studied biology here in Munich, but then went to study ecology and diversity at Innsbruck University, which is a mountain university. The closest one from here, you can get there by train. And even before that, after the Abitur, after the high school degree, she went to Canada. Again to the mountains, to Banff National Park. And she worked in the National Park there. Not a great job, she told me. It was a job where you had to, she was the supervisor of housekeeping, which means that you have to check the bedding and soaps, whether all the utensils are there. But she loved the park, and she thought, maybe one day when I grow up, I want to be a national park person. I want to work in the national park, be in the mountains. And that's where she ended up. So after studying in Innsbruck, she went to the University in Frankfurt. Actually, she does her PhD in Frankfurt, but she's really located in 3 different places. I don't know how she does it, but she is actually a PhD student in Frankfurt working on biodiversity. She's also working in a research team at the Technical University here. So this is Frankfurt. And she's really in the National Park in Berchtesgaden, but now I see that she's part of an ecosystem dynamics and forest management group. And
that's still true.
And all this. So I asked her, is there a fun fact? And she said, there's no fun fact, but yesterday she wrote me an email and she said, well, there is a fun fact about me, and there is something that you would not expect from a biologist. I love waiting. I mean, not waiting in line, but waiting in a bar. And she's one of the people who would serve you at the Oktoberfest here in Munich. So this is not why she's here today. She's here because of the biodiversity research at Berchtesgaden, and we can't wait to hear from you, Lisa. And please join me in welcoming Lisa Geres.
Thank you. Yeah. Hi. Hello from my side as well. Thanks very much for the kind introduction, Christoph. But I have to be clear, I spent most of my time in Berchtesgaden. I'm not that impressive, as he says. So yeah, I hope I can keep up with your expectations now. So Christoph asked me to tell you a bit about our biodiversity research at Berchtesgaden National Park. I know some of you have already seen our research sites in Berchtesgaden, some of you haven't. So I'm going to show many pictures again. But for those who already have seen our sites, I'm going to focus a lot more on the study design and on the background, why we do what we do. And I unfortunately won't have time to talk much about any results, but I brought some, so maybe we can discuss them after the talk if you like. Just a brief background. I'm sure you're all aware that biodiversity is quite important, otherwise you wouldn't be here. And that you probably also know that we're currently experiencing a biodiversity crisis. So to show you just one example, Diaz and Mali here published a review this year where they looked again at the extinction rates that different researchers calculated for different groups of species in human times and in pre-human times. And they showed here quite nicely summarized that the human times extinction rates are 10 to even 100-fold higher than they used to be before humans appeared. So yeah, I guess that's quite an important reminder that we really need to protect our biodiversity. And they also identified the main drivers for this biodiversity crisis, which is land use, direct exploitation, and climate change mainly. And although climate change is not one of the most important drivers here, they also said that it's going to be more and more important in the future. So being a national park in Berchtesgaden, of course it's our job to protect nature and to conserve biodiversity. And to be able to do that, we need to know how our communities are doing right now under climate change. To give you a little bit of background on Berchtesgaden, some of you might not know it. So it's in the very, very south of Germany. It's really almost in Austria, and it's in the northeastern part of the European Alps. And that makes it the only alpine national park in Germany, which of course has a very alpine character. So it's a home to many alpine specialists like capercaillies, for example. And it has a very steep elevational gradient. So you can go from 600 meters to 2,700 meters within just a few kilometers of distance. So that location itself is quite interesting, but the fact that we're a national park makes it even more interesting because we have a lot of natural dynamics happening. This comprises, on the one hand, bark beetle infestations and wind throws, so the kind of stuff you'd see in any forest if it weren't managed. But this also comprises, disturbances that are typical for mountain areas like avalanches or landslides. And this together results in a mosaic really of a really wide range of different kinds of habitats. As you can see here, these pictures were all taken in the national park. So we have mixed forests, we have these disturbance patches, we have mountain pastures, so we do have some land use, and we have different kinds of open areas. So yeah, in addition to our motivation to study biodiversity, this also delivers us a really cool landscape to do that, because we have many interesting habitats we can compare with each other. One thing we don't have, though, is historical data. So there's a problem, because how are you supposed to study climate change effects if you don't have any long-term data? Does anyone have an idea? No? No, not just cars? Yeah?
Maybe through records of like churches or private people that took their own record of biodiversity or the climate conditions?
It's also a nice idea, but it's actually even easier than that. What we're doing is a so-called space for time substitution, which is quite a common concept in ecology. And the idea behind that is you're using a natural gradient that you have. In our case, we have a lot of elevation, so why not use that? And elevation also comes with a temperature change. So if you go up 1,000 meters, it gets about 5 to 6 degrees colder in mean annual temperature. So we have that gradient, and we can now use it to predict the effect of temperature changes on a community. So if you want to know what how a community will be affected when it gets 3 degrees warmer, you can just go to a given elevation, look at the communities there, then go down 500 meters, look at the communities there, and you find out something about the effect of these 3 degrees in temperature difference. And this is a simple concept that doesn't just work for temperature, it works for natural succession as well, for example. So if a farmer abandons a farm, a pasture, it will get more and more shrubby and eventually end up as a forest. So if you want to know how that affects the community there, you could either go to that pasture every year and, survey the community and see what changes, or you can look at already existing shrublands and forests and compare the communities to predict how the pasture is going to change. So of course, this is not exactly the same as looking back, and it comes with some simplifications and with many limitations. So what we're doing at Berchtesgaden is we're using this concept for our current survey that we did in the last 2 years, but we also use this as a baseline for long-term monitoring. So on a subset of our research sites from the last 2 years, we'll survey biodiversity with the various methods I'm showing you later every year from now on. So in a few years we'll actually be able to say whether our predictions were right or wrong. So that's quite a cool add-on, I think. And yeah, so I said before, we're making use of our natural gradients, and I also told you that our natural gradients we have, or that make Berchtesgaden so typical, are the elevation gradient and the habitat or the successional gradient. And what we did now is we set up research sites in different habitats. So we have 9 different categories of habitats spanning anthropogenic open lands, so managed areas, pastures basically. Then we have natural open lands and we have forests. And these habitats span different elevational belts. So natural open lands are the only habitat that also appears above the tree line. And the other types are still spanning 3 different elevational belts. And as most of you probably know, in statistics you always need many repetitions to actually draw any conclusions from the data. So we have many repetitions of these combinations of habitat and elevation. And we ended up with 213 research sites that are spread throughout the whole national park. And this spread is, well, on the one hand, because we need to kind of make use of all the space we have, but also to cover all the different landscapes within the park. For example, up here at Reiter Alpe we have mountain pine, which is one of the only mountain pine populations in Germany. And here we have a very dynamic valley that has a very, very typical character. I always call it the Alaska of Bavaria. So we have these very different landscapes that we all try to cover with our design. And yeah, that's basically how our research sites are set up and where we sample biodiversity. Now, before I tell you how exactly we sample it, I want you to keep in mind that no organism on Earth is entirely independent of other organisms. So take a plant, for example. It needs nutrients that it gets from the soil, and those nutrients are delivered by decomposers. But it also needs pollinators for reproduction. And these pollinators, in turn, are food for birds. So if the decomposers change under climate change, this will eventually affect the birds as well, even though they have nothing to do with each other directly. So if you want to understand how this whole system changes under climate change, it's not enough to just look at one link, you have to look at the whole system. And this is exactly what we're trying to do. And as you can imagine, we have many different organisms that have many different sizes. So you can't just look at them all with one method, you have to use different ones. So the first thing that we did is we took soil and deadwood samples and we analyzed the bacteria and fungi in it. Then on the producer level, we had botanists who basically mapped all the vegetation on our research sites. And on the consumer level, there's again different methods because mammals and insects still have pretty different sizes. So we use different kinds of traps to collect insects and other arthropods. We used sound recorders to collect the calls of birds and bats. And we used different kinds of camera traps to collect data on mammals. And, last but not least, if you want to understand the effect of the environment on biodiversity, you have to know the environment. So we also took data on that. We had students who measured the light availability, the forest structure, the amount of deadwood in the forest. And then we also used these nice little data loggers who measure local temperature and soil moisture. And we analyzed the soil chemistry in our soil samples. And yeah, as you can imagine, using all these methods, first of all, requires a lot of material. So you can see a lot of wood on these pictures that has to get to the plots somehow. And you also see a lot of expensive devices like these badcorders. We don't have 200 of them because one is already quite expensive. We have 20 of them. So they only stay at one site for one night and then they're rotated to other sites. So all in all, we had to go to each site about once every 2 weeks. And yeah, so you can imagine we can't walk to all these sites. Some of them are like a 2-hour hike away. So I just want to take a moment to really appreciate our huge team of interns and also very motivated staff who made all this possible, and also appreciate the really great funding we have, without which it would not have been possible to do such a study in such a dimension. Yeah, just for you to keep in mind, this is by no means the standard for biodiversity studies, which of course makes the data even more valuable. Yeah, so thanks to the team and thank you for listening, and I'm looking forward to the discussion.